the another surface. So it's a wear out or the losses of the material. It is called tribology. If you see these images in these slides, you are observing a lot of materials is sliding and rubbing in the lubricated conditions, and also in the engine components, in the bearing components, and also so many in the chute liner, and also in the mining applications. It is also there is a worn out of the materials will be taking place. So the introductions of the tribology. Tribology means it is the science and technology of interacting surfaces in relative motion. So it means one material is rubs with another material. There is a losses of progressive losses of the materials. It is called tribology. It includes the study and applications of the principles of friction, lubrication, and wear. The tribology is interactions of solid or composite surfaces exposed phase with interacting materials and environment may result in a losses of the materials from the surface. It is also losses of the materials. In the lubrications in the hip joint, it is also losses of the materials. So these are all losses of the materials. How to improve the wear losses? How to improve the wear resistance of the materials to avoid the losses in the many applications. So tribology means not only in the case of engine component or any environment. It's a process. Losses of materials is known as the wear. So in the tribology means not only tribo. Tribo means there is some mechanical applications of the components by means of a pressure, by means of a compressive force, or by means of a tensile force. There's a losses of the materials taking place in the different seals, gears, bolts, nuts, bearings, cams, wheel brakes, clutches, impellers, wheels, etc. So these are all the automobile component. Some of the wheels it's high friction coupled with low. The friction is high, but wear is said is in that case brake pads, clutches. And sometimes the friction will be low wear properties under dry riding condition. Again, it is smooth metallic counterparts. Example, friction will be bearing oils and also in the gear conditions, engine oils in the gears, in the automobile sectors. We are using oils, lubricants generally we are using, but not in the case of brake pads and clutches. So generally, wear means it is the interaction. So the wear resistant materials, brake clamps, clutches, and also tire and our shoes, frictional heating, example, initiating a fire by pre-heuristic peoples, and also in the brake, etc. Wear resistant materials, where asbestos type of materials is prepared. So in that case, it can possible to minimize the wear and minimize the frictions, enhancement of adhesion. Say simple examples: eraser, friction surfacing. We are not using any lubricants. Enhancement of adhesion. By means of the rubber, say eraser, it's a materials by applications of the press. So sacrificial materials is pencil positions of a highly lubricated defined as a stuff, lubrications, friction, and also impacted by motion, sliding, rolling, speed, temperatures, load, operating environment, lubricant, and applications methods. These are all the very important concepts we are using in the present of this kind of environment. So in our presentation, this is the special talk we are going to presentation in the through understanding the tribological properties. Generally, as per our talk is related to a composite materials. First, you all you understand what is composite materials. Composite means it is the macroscopic combination of two or more materials. It is called composite. There is a different types of composite materials. In nature. In nature is natural composite. The nature is shell. In the seashores, calcium carbonate and it's a mixture. It is also one of the composite materials. In general, composite materials is a man-made composite materials. It is a there's a recently it is a aerospace application. So generally, it is using a glass epoxy composite. Generally, using epoxy is one of the major major usage of a composite materials, usage of a composite materials at present technology, at present science, and also Kevlar fibers, and carbon fiber. It is also one of the major applications of aircraft sectors, carbon fibers, and also Kevlar fibers. So nowadays it is a natural composite. It is a jute is one of the composite materials is using jute, sisal fabric, sisal materials, areca fiber. These are all the materials. It is used for in the inner part of the automobile sectors and also in the aerospace sectors is also using. Generally, it is using. In the shipbuilding industries is also more using in the what about in the shipbuilding industry is also using. ಸರಿಯಾಗಿ ಕೈ ಕೊಡ್ತು ಇಲ್ಲಿ ಕರೆಂಟೇ ಪಾಸ್ ಆಗಲ್ಲ
Sir, Dr. Mohan, sir.
Sir, 1 minute. 1 minute. Some problem in the. Yeah. 2 minutes, sir. 2 minutes. Yeah. Sir, visible, sir, slides.
Yes, sir, visible, sir.
Hello.
Yes, sir.
Hello. Yeah, visible. Sorry, sir, some battery connection problem. So now it is okay. So now we are using different materials. Generally in the generally in the tribological properties been very important. More than 90% the composites, failure of the composite parts in actual service are due to tribological environment. As per this, we are selected for composite tribology only. So not metallic tribology, not alloy tribology, because of only it is spread. So now everywhere in the composite, 80% of the composite material to reduce or aluminum, titanium structures in the composite materials. Enter of the materials is made up of a natural composite. Outside is a the fiber reinforced composite material. So we are going to study. We are studying different types of materials. Different types of material, metal materials, some max composite material, and polymer matrix composite material. Apart from that, composite materials, polymer composite.
Mohan, sir. Mohan, sir.
Hello, 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 hello. Now it is connected, sir. Some network issues only. Now it is connected. Now it is connected. So now the composite materials is one of the latest. So you are introduced. Hello,
Sir,
hello, sir.
share your screen, sir.
Yeah. Okay. Yeah. 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 Okay. So now the composite materials. Say here it is introduced. These are the different types of materials. So if you go to study the friction and wear, there is a different types of wear: sliding friction, rolling friction, boundary friction, mixed film friction, and fluid
Sir,
friction.
still your screen is not shared.
Yeah. Hello. 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 Hello.
Yes, sir.
Sir? Yeah.
No,
Okay.
sir.
Okay. I will improve the speed. Okay. Okay. Hello. Visible slides.
No, sir.
Hello. So it's now again we are going to some of the types of wear is adhesive wear, two body wear, three body wear, and surface fatigue. So causes of heat generations, losses of viscosity, increase the.
Kindly share your screen, sir.
Yeah. Okay. Sorry. Okay.
Now, okay, sir.
Yeah. Now visible, sir? PPT is visible? Hello?
Yes, sir. Yes.
Hello? Sir, PPT visible, sir? Sorry.
Yes, sir. Visible.
Hello? Yeah. So it's a material removal from the solid surface by means of actions of another surface. It is the propagation. Hello? Propagation of a cracks and the materials will be fractured in general in the material. Similarly, in this, so applying the lubrications in between the balls and bearings, there is a one liner will be there. That is a composite materials. That is a polytetrafluoroethylene is the one of the materials. It's a made up of a glass fabric is reinforced with polytetrafluoroethylene. It gives self lubrications in the bearing liner materials. So and also lubrications. Instead of lubrications, we are introducing a bearing liner. So there is some research facility in our college. There is a pin and disk machines. We can possible to use the test the machines, test the composite samples in the pin and disk machines, and also in the erosive is also possible. There's a possible to erosive in the high temperature environment. There is a solid particle interactions with the micromechanical actions of the solid particles interactions with the surface. There is a progressive losses of the materials. It means the impact of solid particles. There is generally it is a removes the materials on the solid surface. Such a kind of a testing facility is also available. So this is the erosion where say erosion will be taking place. I will show before this some 2 minutes one video. I will share the video.
We are Society of Ecologists.
So hello, visible? Visible?
We are leading
Hello?
researchers in the field
Sir, visible?
Yes, sir.
Yes, sir.
Yeah.
Hear the word tribology, but you can see tribology in action on a daily basis with cars, wind turbines, and in sports as a few examples. You'll see it best in applications with sliding, just like here, where if you zoom in with microphotography, you'll see the top steel plate sliding across oil. As you can see, the oil separates the two steel surfaces. This right here is tribology. It is the study of surfaces moving relative to one another. So when surfaces are rubbing together, we tribologists look at three things: friction, wear, and lubrication. Friction is the resistance to relative motion. Wear is the loss of material due to that motion, and lubrication is the use of a fluid, or in some cases a solid, to minimize friction and wear. Now the cool part is seeing tribology come alive through our research. Check this out. When your finger rubs against the surface, basically the sliding force of your finger acts against the friction from the surface. Now with our research, we can put numbers to that friction. Watch this. Instead of a finger, let's look at a steel ball rubbing against a steel plate. As the ball rubs across the surface, data is being collected. At every location, we are getting the coefficient of friction. For example, at one location, the friction coefficient is around 0.17. And at another location, it's 0.15. Altogether, the data shown tells us the average coefficient of friction is around 0.16 for the surface. You can think about what you've learned in class and apply it. How can we control friction? How can we control wear? Can we apply lubrication? Today, our research group helps answer these questions.
So right now, we're looking at some interesting lubrication properties of the non-ferrous bearing material. It's a new alloy of nickel titanium, so it's called nickel. There's not a lot of research been there into lubrication, though, because all commercial lubricants have been designed to bearings, which are promising bearing material for all sorts of applications in space and tertiary.
So each sample that we create here has different additive combinations, and these are meant to keep the oils stable throughout varying temperatures and in the long run. What we also do is make sure that these oils don't produce foam. Once it starts developing foam, then you have bubbles, which pretty much exclude the oil, and you have the materials rubbing against one another, which produces the wear, and you lose energy from friction.
Oil degrades, and one of the main degradation channels is oxidation. This problem across every industry, the transportation industry and the power generation industry, that artificially degraded oil on the steel component. We take this steel component bottom, we expose it to differing chemicals and environmental conditions like temperature and flow rates to see that if we can remove the varnish.
I work with lubricants. That's my sort of topic in tribology in that giant umbrella field. And with my computer science knowledge, I do simulations. So I model base oils, essentially oils that formulate lubricants, and I model them and calculate the viscosity. Ultimately, if we can predict viscosity using computers, that would be really helpful for formulating new.
As you can see, tribology is both technologically relevant and scientifically fascinating. One thing's for sure, get to be a part of this growing field of research.
Hello, audience. Hello, hello, hello.
Yes, sir.
Hello,
You're audible, sir.
hello, 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 hello. So that all the parties, I hope you're under video. Now we'll go to where are landslides in the transports moves from sediments down hills to one place another places. In the mining applications, there is a bottom is parent.
Sir, please share your screen, sir. Mohan, sir. Please share your screen, sir. Slides not visible. Your voice also not audible. You are muted, sir. Please unmute yourself. Mohan, sir, please unmute yourself. Slides, sir. Share your screen, sir.
Yeah. Okay. So this is the various stages. Yeah. Screen is sharing or not sharing? Okay.
Your screen not visible, sir.
Yeah. Now, sir. Now it is visible.
No, sir.
Hello.
Please share your screen, sir.
Yeah. 1 minute. Yeah. Now it is visible, sir. Hello?
Yes, sir, visible.
Yeah. Okay. So this is the various stages of sliding wear. I hope all of you visible in the shape. No? So abrasive wear, two body wear, and three body wear. So two body wear means there is a particles will be abrasive powders will be fixed in the particular junction. And the three body means there is a movement of the particles between the two bodies. So erosive wear it is means the erosive wear mechanism. Properties of the target materials is composition, structure, fiber filler matrix, and erode. Hello, 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 hello. So screen is visible. Hello,
Yes, sir, visible,
hello,
sir.
hello.
Please continue, sir.
Hello. Thank you, thank you. Thank you, thank you, thank you, thank you, thank you. So this is the test parameters. So it's the angle of impingement, particle velocity, temperature. This is one of the tribology. So there is a generally 4 to 5 types of tribology. In adhesive tribology, three body tribology, two body tribology, and erosive environment, erosive, and also one more corrosion is also taking place. So two body where the applications it's going on pipe, chute liners, transport abrasive materials, rotors, powder mixtures, pivot pins, construction machinery, blades. Three bodies, three bearings, bushers operating in abrasive environment, lower sleeve bearings in vertical switch pumps, vertical spring bushers. These are all the environment going to test the three body environment. This is olden days. The record player is a prolonged period of time. Record player will be a disc will be worn out. So after the sometimes so there's a pin is also worn out under the time. So this is the machine is it is there in our research center. So we have tested a lot of composite materials and also a lot of materials is also done the testing. I'll show this video after the sessions. This is the erosion in vehicle and the plant. So aircraft in moving in the desert environment or in the open atmosphere. So the rotor blades is also worn out. Jet engine turbine blades is also worn out. Damage. It is the causes of the damages. It is due to dust and sand, and also radon. It is covering the radar. It is called radon. It's also damage will be taking place. Wing leading edges is also damaged. Satellite surfaces, atomic oxygen and space debris. In power plant, generally piping, fitting, cyclones, valves, and also turbine blades. In the boiler plants, they are due to charcoal moving at a speed up to different velocities. There is a damages will be taking place. On the oil refinery in the chemical plants, say riser, refrigerator, refiners, pipelines. There's a fine catalyst is used in refining. Here is also erosion is chemical in the environment due to reactions, chemical reactions in the environment. Oxidation will be taking place. So in that case, there is a formations of the film on the surface of the materials. There is a reduce the strength of the materials after a prolonged period of time. This is known as the corrosion where will be place. So this is schematic representations of the basic tribological interactions related to vehicle generation. Tribological interactions will be taking place load friction and stress surface fatigue and abrasion. So surface fatigue means there is a cyclic fatigues or cyclic stresses. So there is a long period of time using there is a changes in the crack formation and also materials will be damaged and delamination due to and also fatigue where say particles say micro and nanoparticles is worked at. Abrasion is a micro cutting, micro flowing, and micro cracking in the materials, in the abraded wear particles. And in the materials, interactions is tribochemical materials due to adhesive joint formations and rupture. So adhesive wear particles. This is the general applications of a fiber reinforced plastics in different fields. Bearing liners. There's a polytetrafluoroethylene materials are used in the case of the bearing liners materials. Generally, instead of oil or instead of ink, there is a self lubrication will be a taking place. So this is generally is made up of from the composite materials. Applications of fiber reinforced particles in the different fields. It is wind turbine blades, in the chemical pipes, pipelines. It is using. They are all surface. There is a wear and tear will be taking place in the materials. To avoid all the such a things, we are using some kinds of a filler materials in the polymer matrix composites, and also applications of FRPs in the different field sections in the helmets, and then electrical applications is also using. In tire, they are using some kinds of fillers is using. In aerospace, marine applications, in the steam boat, automotive and other applications in chassis is using a carbon fibers, so are using generally in the automotive and other application, and also in the bumpers in the trucks is also using materials called fiber reinforced synthetic fibers are using. So in the present talk investigation, role of graphite. Graphite is a one of the non metal but good conductor of electricity, and it is acts as a self lubrication properties in the material. Silicon carbide and tungsten carbide is hard powders is also introduced in the polymer matrix composites. It's enhance the wear resistance properties is studied in both sliding wear and also in the abrasive wear and also in the erosive wear environment. So generally in the Jatropha, it is one of the cultivation of Jatropha. It is after crushing the Jatropha, it is used for like a diesel in the engine. After obtaining the husk in the Jatropha, that particles is also using in the glass epoxy composite materials with the different combination, different percentages. It is also gives the enhancement in the wear properties. So and also in the mechanical properties also we are studied, and sliding wear behavior it is also studied, and also solid particle erosive wear behavior it is also studied by using a filler filled glass epoxy composite. Before fabrication, how the glass and aramide fabrics 210 and 360 GSM, and also using a bifunctional LY epoxy composite. Epoxy matrix materials is used for the fabrication of a polymer matrix composite materials. Here the materials is filler materials is using in this study. So it is purchased from the different organizations. So next, the fabrications methodology of nano composites. If you use the nano fillers, it is called as nano composite. If you use the microns level, we are called as a general composite materials. Fabrics are cut into required dimensions and placed in the mold, and mixing the epoxy resins with the filler. The epoxy means it is general adhesives. So what you are using for joining the pipelines and all those things, you are asking the materials. It is called adhesive. It is similar to this is the epoxy. These two things are manufactured by using a vacuum-assisted resin transfer molding technique, and then it is a curing by bagging system, 0.965 megapascals and up to 24 hours in the room temperature, and then post-curing in the autoclave up to 100 degrees Celsius, controlled oven up to 3 hours. Fabricated composites are cut into required dimensions by using a diamond tip cutter. So after this is the schematic diagram. The filler in the ultrasonications in the filler. After that, you are pouring these materials into fabrics. After that, the fabric is cured in the hot compression or vacuum assisted resin. One of the technologies is using from the past to 20 years in the aerospace sector. A granite molding tool, dry glass fabrics, or a Kevlar fabric, any type of fabrics, and peel play and breather metal on one side, and the vacuum sources suck the resin. Resin is mixed with some kind of a filler, and then vacuum back. The pressure is developed in between the fabrics. So then the materials will become in the breather, or also excess amount of resin is observed in the breather outside the materials. after vacuum cell came up, the material is ASTM standards. So there's a tensile impact and also wear is also going. This is the semi images of a before fabrication and after fabrications of the after incorporations of the fillers in the materials. This is the impact strength is studied by filler filled composites. Is the graphite, it gives the more impact strength and more hardness as, as compared to the normal glass epoxy composite materials. This is the test conditions, dimensions of the specimen, applied load, angular speed, sliding diameter, and sliding distance. These are all the general simple parameters. We are not using any orthogonal array or any other techniques here. So disk is made up of 54.65 RC. This is the high temperature pin on disk machine. It is in the National Institute of Technology and also in the Dr. Ambedkar Institute of Technology is also available. This kinds of a facility. This is the pins are made as a small samples are made and it is fixed in the holder and then it is a run according to the this load is 10 to 20 and Newton and also revolutions is set at the fixed revolution or sliding diameter. P is 1 by 60 velocity is set. So this is the material. This is the weighing. We are taking the weighing the sample that gives the weight losses of the material. So here weight losses is a chuck with a different temperature polymer matrix composite. It gives the very good wear resistance as compared to the general materials. Because of the lubricants like materials in the graphite, it enhances the wear properties of the materials and also it gives the very good wear properties, very good tribological properties. Generally, this kind of materials can possible to use in the bearing liners. Instead of polytetrafluoroethylene, all the materials will be costly. Why you are using the filler materials to cost reduction? Import filler materials using the polymatrix composite. There is a cost reduction and also improve the mechanical and also tribological properties. Here we are studied up to 90 Celsius. We can possible to stay up to 200 degrees Celsius based on the depending upon the matrix. Here since epoxy it is the matrix we are using. The epoxy matrix it withstands the glass transition temperature of the epoxy matrix up to 150, 160 or 120 degrees Celsius. That's all. If you use the phenolic composite, we can possible to use the 300 degree Celsius or 3 degree Celsius in the possible to use in engine components of the matrix. This is the specific wear rate versus temperature. So here glass epoxy composites on the graphite filled composite, it gives the very good specific initially it is a drastic lower the specific rate. After increasing the temperature, the specific rate will also be increases. Low we are observed in this graphite field composite. And also coefficient of friction is one of the very important phenomena we studied in the graphite filled composite materials. Here graphite filled composite it gives the lower the coefficient of friction as compared to the because of solid lubricant there is a formations of the thin film between the in between the two components. So this gives enhance the wear resistance of materials and also there is a formations of the thin film in between the composite specimen. It gives a good lubrication properties. There is no need to add any extra lubrication. In the material itself, inherent in the property of the materials, it gives the actions will be taking place. After testing the materials, we are going to study scanning electron microscope, warm surface morphology of the surfaces. We are studying the different wear mechanisms in the materials. Generally, the wear mechanisms at the different low load and lower temperature and higher temperature. Higher temperature is the same images of unfilled. So higher temperature just be generally obviously breakdown is more as compared to the lower. So here fiber breakages, formations of walls, fiber and breakages, and also the glass protect the glass fibers in the epoxy trays. All the things we are studied. Sliding directions is also studied. Temperatures, the lower the damage, higher temperature it becomes. Higher the damages, broken fiber end appears in the form chipped features, worn out main layer damages surfaces. Some images again filled glass epoxy composites. Again, this one. So graphite filled composite it gives the more very good lubrication property and also protect the composite polymer matrix composites from the wear. So it's a more wear resistance because of solid lubricants and also it's reduces the friction in between the two materials. So the summary of this kind of testing, this kind of research and applied load, wear performance of unfilled glass epoxy composite process, strong wear mechanisms we have observed in this one. So again, investigation going to introducing a Jatropha oil cake materials in the same sliding and same parameters and the room temperature, not a high temperature. So we are observed this is the glass epoxy with the filler is Jatropha up to 6%. This is the natural composite, natural filler after extractions of the oil from the Jatropha, we are using the Jatropha oil powders is using. These are all the mechanical properties. By introducing these are all the fillers in the material modulus and also some of the hardness is less as compared to this one. Hardness will be reduced, but the product of the mechanical properties is a very good mechanical property. So this is the specimens is standard tested on the ASTM standard. Here it is a Jatropha field. A is the general composite material as compared to filler field. See where debris and also fiber pullout, fiber reinforcement, all those things as compared to normal composites shows the more mechanical enhancement of the more mechanical strength in the filler field Jatropha natural composites in the polymer matrix composites materials. Force transducers, lever arm, all those things, the samples is tested in the different environment. JFC G is 10 Newton and 20 Newton. The wear losses or the wear, so JFC field composite, it gives the very good up to 8,000 meters. We are a sliding distance. We are studied these materials. This is specific wear rate. There is a drastic reductions of the materials will be taking place, and then linear reductions will be observed from the 4,000 to 8,000 meter. Because of why the drastic reductions we are observed in the both the materials, there is a epoxy, a softening nature of the epoxy materials initially. More amount of matrix presence in the surface of the composite specimen. Initial contact of that materials, its more specific wear rate will be drastically reduced. More wear losses will be taking place. After that, Jatropha oil cake and also a glass epoxy composite will play in between the two surfaces of the materials. It becomes enhancement of the wear resistance of the materials. It gives the wear losses is very less as compared to filler filled JUC composites. Here you are observing the glass epoxy composite, JOC field composite, it gives the more wear resistance in the specific wear rate you are observed. Say A and B. A is a lower the load, Newton load, and B is the higher the Newton load is observed. So this is the coefficient of friction is also coefficient of friction will be a mixed fractions we are observed, but as compared to glass epoxy composite, oily nature of a Jatropha oil cake, it gives the a very good coefficient of friction as compared to in the general composite. composite material. These are the semi images of the different composite materials. At the lower the distance and higher the distance. Generally, higher the distance, the materials will be more worn out will be taking place. More damages also observed as compared to the lower distance. And also, if you apply the more load at the more distance, more damage will be observed in the diagram. D, matrix damage, voids formation, fiber break in the form of a chip for outer features. Some images, geometry field, geometry are some general composite. The jet drop oil cake field composite is the very good wind resistance because of oil inches and also some of the precious presence in these materials. It covers the present pavement materials, envelops the materials, it reduces the wear, it improves the wear resistance. Here we can observe this is the more evidence of the evidence we are observing in this scanning electron microscope. So the summary of this natural filler materials filled in the glass epoxy composite strongly depends on the experimental test parameter, sliding distance on applied load. Wear losses increases with decreases in fact on applied load. Where drop oil cake is one of the natural materials in the system. Specific wear losses also decreases with increasing the sliding distance. Changes in the coefficient friction in the mixer factor, but also JOC is filled lower the friction. It acts as a lubricant in the materials. It's a self-lubrications properties. It can possible to use these kinds of bearing liner and some of the applications in the major SEM images indicates the matrix debris formation in the materials. Some of the major SEM images indicates the matrix debris formation in the materials. Hello, if you visible? Hello, if you visible? Hello?
Visible, sir.
Yes, sir.
Visible? Okay, I will continue. So, here, one of the professor from the Denmark, Daniel, is visited in our machines. How the setup in the pin and disc machine, both normal and high temperature. High temperature. So here. So this is the materials testing in high temperature environment. So it can possible to test the materials up to 1000 degrees Celsius, but polymer matrix is not possible to test up to 1000 degrees Celsius. This is the next we are going to impact on solid at more than 800 degrees Celsius. This is the metal matrix coated composites. Thermal barrier coated composite is used in the different angles we are studied in this material. All of you visible? All of you visible, sir? Audience? Participants? Dear participants? Hello? Hello? Hello?
Sir, visible, sir. Visible,
Hello?
audible, sir.
Hello, visible, sir? Yeah, 1 minute, sir. Network is connection taking.
Okay, sir.
Yeah.
Continue, sir.
Visible, sir? No? Hello?
Yes, sir. Yes, sir.
Hello? Hello? Yeah, shall I continue, sir? Shall I continue? There's one more video is there. Okay. Is visible, sir? No visible? Shall I play? Hello?
Yes, sir.
Visible? Hello?
Visible, sir.
Hello? Hello, sir?
Sir,
Sir, visible?
visible, sir.
Hello? Yeah. Okay. So this is the one of the impact of the material. So generally high pressure, high load, high weight. So the rubber material, rubber type of materials, there is no sound is observing in this case. Okay, I'll continue. Hello?
Okay, sir.
Hello? 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 Yeah, okay. I will continue. So now we'll go to impact. So impact means what you understand impact. There is a sudden drop of any materials. The material becomes a breakage. The fact of taking place, there is a repeated impact load of the materials. Generally, a vehicle is moving in the desert environment. Uh, Micro mechanical solid particles or interactions with the surface of the materials, there's a progressive damage will be taking place. In general, any vehicles, say like aerospace is a glass fiber reinforced, glass fiber reinforced. It is made up of the materials. The vehicle is taking a takeoff, or a vehicle is landing. So there is some dust particles. So there's a dust particles. It is called silica. It is an interaction. Materials will become damaged. So in that case, to avoid such a things, here we are generally we are researches investigations will be going to introducing place. Here it is also impact is taking place. So generally the impact is these are the images we are observing the impact. This is the erosion testing machine. Erode pipe from the hoopers and also conveyor belt system. Particles are mixing chamber, pressure transducers, nozzles, sample holder. This is the generally silica sand is used for the erodent. It is used. These materials will hit the parent materials that are polymer matrix composites. Its a size is and also mechanical properties is also checked. The main properties is the impact is one of the very important properties because of here erosion is the combination of impact. The impact strength is observed. The hard silicon carbide covalent bonding structures in the materials in the Jatropa oil cake materials, it gives the very good impact strength as compared to the JOC graphite and graphite glass epoxy and pure glass epoxy composite. Here impact versus strength versus displacement in mm. It is tested in the composite in Indian Institute. Fiber pullout is very less. Here fiber pullout is more fiber pullings are observed. So this gives the more strength in the impact in the more impact strength in the JOC glass epoxy. JOC is filled in the glass epoxy composite. This is the erosive test setup. So different angles we are studied the composite materials in the different angles. This is the way scars the different angles. Say 60-degree, 30-degree, and 90-degree angle for a graphite field. There is a dark color is purely a graphite field, and a light dark color is a JOC graphite field. The JOC field glass epoxy. So silicon carbide field glass epoxy composite is white is the pure glass epoxy composites we are observing. So these are all the where here erosion rate versus angle of impingement study. Say 90-degree, 60-degree, and 30-degree. Here pure JOC composite it gives the very good erosion rate as compared the other this one. So here we are erosion rate. So different velocity. So velocity means the particles in the silicon particles hitting this specimen at the different velocity. The lower velocity you are observing, say, between is the value erosion. So higher the rate you are observing in this diagram. The erosion resistance in the sequence is Jatropha oil cake filled glass epoxy composite is the more erosion resistance as compared to the all other composite specimen. It is in the yellow color highlight. The highlight is represented in these slides. So variations in impact velocity. So this is the erosion rate with respect to impact velocity. Here it is also we are observed JOC field glass epoxy composite. Again, semi-majors impact see Jatropha oil cake field glass composite fiber breaks matrix with JOC 25 from the damage. This is less damage as compared to other composite. Here we are observed more eroded surfaces by the presence of silicon carbide glass epoxy composite samples. Semi-majors of eroded composites observed. So this is the unfilled means without any filler filled composite. More wear scratches, more fiber bending, fiber crushing, cup and fair observed. Semi again the top mixture of silicon carbide is also more fragments fibers is observed. Here also crushed and fragments fibers semi-major surface. The corrosion where behavior strongly depends on the impingement angle and the maximum where is observed the 90-degree impingement angle. As ductile to brittle transitions will be taking place at the 60-degree impingement angle. Incorporations of a Jatropha oil cake, say composite shows say becomes a more strength and more bonding will resist the damage of the materials. And also glass epoxy with a graphite filler shows the highest erosion rate due to weak bonding strength between the filler and the matrix. Here good carbide and oil cake filled composite. The presence of hard carbide in the glass epoxy composite gives more considerable improvement in erosion resistance as compared to unfilled JOC and graphite fill. Some images it supports the evidence of the more wear mechanism is observed in the some images. So and again, what is that? Kept it in taking in the seawater environment. Testing is also going to continue to test the materials. So Jatropha bubbles burst. So if you use the Jatropha, can possible to in the different field. Say that Dr. Abdul Kalam sir says more cultivation of a Jatropha oil cake as based on the little it is a blooming and also it is a dream was oiled on a type you can use the oil of the materials planning commission triggered and like much of what does is actually release industrial projection and also improves the industry the cultivations of the Jatropha and also use more and more Jatropha in the technical in the science and technology field.
எது நானா அவரு ஏதோ எடுத்து போறது அவ்வளவுதான் முடிஞ்சுச்சு. Thank you, sir.
Hello. Hello.
Thank you,
Hello,
sir.
sir.
Thank you, sir. Now the
Hello, sir.
hello, sir.
Hello.
Audible,
Question,
sir.
sir, please.
Yes, sir. Yes, sir. Now the forum is open, so the participants can raise
No
your
questions.
doubts and questions. Thank you, sir. Now I invite Professor PSN Raju garu to invite vote of thanks.
Sir, thank you, sir. On behalf of the management, principal, vice principal, and Department of Mechanical Engineering, Swarnandhra College of Engineering and Technology, Narsapur, Andhra Pradesh, we extend our heartfelt gratitude to our today's speaker, Dr. N. Mohan sir, Professor, Department of Industrial Engineering and Management, Dr. Ambedkar Institute of Technology, Karnataka, who has shared his expertise in this knowledge sharing platform on the topic recent advancement in tribology and composite materials. Sir, your session was incredibly informative and we are grateful to you, sir, for accepting our invitation at short notice. Much thankful for your representation being a section speaker in this FDP. Thank you, sir, once again on behalf of organizing committee and on my own behalf, I extend my sincere thanks to you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you.
Thank you. Great to
Thank you, sir. Thank you, sir.
Dr.
Thank you, sir.
Swarnandhra College of Engineering and Technology. Unleash your potential. Build your career here. Godavari Delta in Andhra Pradesh, with its finest soils and pleasant waters, is the richest region for its age-old traditional and cultural heritage. The Vasishtha Godavari, a tribute of river Godavari, flows fluently with all that vibrant iridation spreading along its banks.
Our college was established in 2001 by the Vasishtha Education Society to produce global, competent and dynamic professionals, creating Center of Excellence in Technical Education for Empowerment. Apart from curriculum, we train in the latest technology like data science, VLSI, Python, full stack, Java full stack, SAP, process integration, ABAP, FICO and ERP.
Swarnandhra College of Engineering and Technology in Narasapur of West Godavari, vicinal to Vasishtha.